Right, good morning grade 10s. We are now going to look at what happens with the different ones that we get. Okay, so gx, okay, I gave you, is a half x squared. Oopsie, let's just put it like that then. Okay, so let's have a look at what happens when we add some values. Remember I said to you, good, let's start with minus 3, minus 2, minus 1, 0, 1, 2, and 3. So, g of minus 3 is a half minus 3 squared, okay, which is the same as saying a half times by 9, which is 9 over 2, which is what? 2468. 2468 is 4 and a half. Do you agree? 8, 9 over 2. Right, g of minus 2 is the same as saying a half times by 4, which is 4 over 2, which is 2. G of minus 1 is a half minus 1 squared is a half times 1, which is a half. G of 0 is anything times 0 is 0. G of 1 is again a half. G of 2, which is going to be a half times by 4, which is 4 over 2, which is then 2. G of 3 is a half times by 9, which is 9 over 2, which is again 4 and a half. Okay, so that's g of x. Let's put down the coordinates for ourselves here. Minus 3, 4 and a half. Minus 2, 2. Minus 1, a half. 0, 0. 1, a half. 2, 2, and 3, 4 and a half. Okay, remember these are the x values that I substitute in there, which is my input values, and these are my output values, which is my y. Okay, I'm going to just do all of them and then we'll sketch them all together. Okay, hx is 2x squared. Let's do the same. So h of minus 3 is 2 times minus 3 squared, which is 2 times 9, which is 18. Wow, my graph's not going to be big enough for that. Okay, let's say h of minus 2. Minus 2 squared is equal to 2 times 4, which is equal to 8. H of minus 1 is 2 minus 1 squared equals 2 times 1 equals 2. H of 0, we should know already by now that it's going to be 0. Huh? Okay, h of 1 is 2 times 1, which equals 2. H of 2 is 2 squared, whoopsie, 2 times 4 equals 8. I'm not going to do the 3 because it's going to be a huge number. Okay, the fx we already did, but I'll just put down the coordinates from yesterday, which was fx equal to x squared, and the coordinates were minus 3, 9, minus 2, 4, minus 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. That's the one we did yesterday. Okay, now let's do the next one, which I gave you, which was px equal to minus x squared. So px equal to minus x squared. So let's see. P of minus 3 is minus 3 squared. Okay, remember I'm only replacing the x, so that minus stays outside. So then I'm left with minus 3 times minus 3 is 9. So I'm left with basically minus 9. P of minus 2 minus 2 squared. So I have a minus, minus 2 times minus 2 is positive 4. And a minus times a plus is a minus. P of minus 1, minus 1. So I have a minus on the outside. Minus 1 times minus 1 is positive 1. P of naught, anything times naught is naught. Okay, P of 1 is equal to minus 1 squared, and that's 1. So we're still left with a minus 1 there. P of 2, okay, that's 4, but there's still got the minus on the outside, so that's minus 4. And P of 3 is 3 squared is 9, but we still got the minus on the outside, so it is minus 9. Right, now I've drawn a set of axes, and now we're going to plot these points that I have here so far. Okay, so let's have a look. We have, where's my pencil? Minus 3, 4 and a half. So I'm going to try and do it properly. So it's minus 3 and I've got 4 and a half. 1, 2, 3, 4 and a half. Minus 2, 2. Minus 2, 2. Minus 1, a half. So that's about there. 0, 0. Okay, 1 half. X is 2, Y is 2. Up there, 1, 2. Where X is 3, I get 4 and a half. 1, 2, 3, 4 and a half. Okay, so that's GX. Let's draw it. Okay, it's a nice rounded graph. And label it GX. Okay, HX. Oh, we forgot to put in the coordinates here. HX was minus 3, 18, minus 2, 8, minus 1, 2, 0, 0, 1, 2, and 2, 8. Okay, so let's have a look at this one. Okay, I'm not going to do the 18 because my graph only goes up to 10, but I can do the next one, which is minus 2, 8. Excuse me. 1, 2, 3, 4, 5, 6, 7, 8. Goodness. Minus 1, 2. 0, 0. Oh, 1, 2. And 2, 8. Okay, so this is HX. Comes down like this. Round. Back up. And that's HX. Okay, FX we had minus 3, 9. Okay, let's see. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9. Minus 2, 4. 1, 2, 3, 4. Minus 1, positive 1. 0, 0. 1, 1. Sure, I've got an itchy throat. 2, 4. 1, 2, 3, 4. And 3, 9. Which was always up there. Right there. Okay, so this is FX. And he goes like that. Right. And then let's do the next one. Oh, we need to do the coordinates for this one too. So it is minus 3, minus 9, minus 2, minus 4, minus 1, 0, 0, 1 minus 1, 2 minus 4, 3 minus 9. Okay, so let's sketch that one. Okay, minus 3 minus 9. Okay, now we're going down to the bottom here. Minus 3 minus 9. Minus 2 minus 4. Minus 1 minus 1. 0, 0. 1 minus 1. 2 minus 4. And 3 minus 9. Okay, and we sketch this parabola. And this was px. Okay, so now this is what I wanted to show you. Gx was a half x squared, right? Fx was just equal to x squared. Hx was equal to 2x squared. And I'm going to highlight them so that you can see them nice and clearly. Right? So, this one was a half x squared. Okay? This was 1 x squared. And this one was 2 x squared. Can you see a trend here with those three? Okay? When you have a half x squared and a normal 1x squared and you have a 2x squared, you will see that the value here, the smaller the value there, the wider the graph. Okay, and the bigger the value there, the narrower the graph. Okay, and then another very important thing is when px was a negative x squared. Okay, so that's then upside down. So what we can say is when fx is equal to positive x squared, you have a happy face. When you have a negative x squared, it's a sad one. Right, okay. Now I'm going to give you some other ones that I want you to try. I want you to try and do fx is equal to fx plus 2 and gx is equal to fx minus 1. Okay, and let's do hx is equal to minus fx plus 3. Okay, remember, do for the values minus 3, minus 2, minus 1, 0, and 1, 2, 3. For those three on the same set of axes. Right, I'll give you a day to do that and then we will mark it. Okay, have a good day, grade 10s.